Okay, this is the proof of Theorem 5, which is the product of two complex numbers. The theorem says that z1 times z2, which are complex numbers, equals r1 times r2 times the cosine of theta 1 plus theta 2 plus I sine of theta 1 plus theta 2. So if we let z1 be r1 cosine theta 1 plus I sine theta 1, and z2 equal r2 cosine theta 2 plus I sine theta 2, we can multiply those two together and have this. Now again, we can rearrange. Because we're multiplying, we can bring the r1 and the r2 in the front. Multiplication is commutative, which means the order doesn't matter. And then we're going to go ahead and FOIL this out. So we take the cosine of theta 1 times cosine of theta 2, cosine of theta 1 times I sine of theta 2, I sine of theta 1 times the cosine of theta 2, and I sine of theta 1 times I sine of theta 2. That's where we get all this. This note is I times I. That's where the I squared comes from. Then again, because we're adding, it's a commutative also, and so we can just reorganize. I chose to bring these two together and these two together because these terms have the I in them, and these two terms are the cosine and cosine and sine and sine. Remember though that I squared is -1. So this now becomes the r1, r2 times cosine theta 1, cosine theta 2 minus sine theta 1, sine theta 2 plus I sine times the cosine of theta 1, sine of theta 1, theta 2 plus sine theta 1 times the cosine of theta 2. From our sum formulas, this works out to be cosine of theta 1 plus theta 2, and this works out to be sine of theta 1 plus theta 2. Therefore, that is what we were looking to prove, so therefore Theorem 5 holds.